This is part 2 of the 3.04 recording. Sorry, I lost track of my time there and it cuts me off at 15 minutes, so we'll just start with this paragraph over. If a substance releases hydrogen ions in water, there is a higher concentration of hydrogen ions than hydroxide ions, and the solution is acidic. The concentration of hydrogen ions is then greater than 1 times 10 to the negative 7th molar. Remember, this number is easy to remember because when something's neutral, the pH is 7. Conversely, if hydroxide ions are released in the water, the concentration of hydroxide ions is greater than the concentration of hydrogen ions. The solution is basic or alkaline, and the concentration of hydrogen ions is less than 1 times 10 to the negative 7th molar. We also want to note that when we multiply the concentration of hydrogen ions times the concentration of hydroxide ions, it's going to equal 1 times 10 to the negative 14th molar. Take a look at acidic and basic solutions. Recall that an acidic solution is one in which the concentration of hydrogen ions is greater than the concentration of hydroxide ions. If hydrogen chloride is dissolved in water, it will dissociate or break apart. When this happens in water, the concentration of hydrogen ions in the water solution is greater than the concentration of hydroxide ions, which makes sense because when you're putting this in, what are you getting? Well, you're getting hydrogen. So of course there's going to be more hydrogen ions than hydroxide ions. What if sodium hydroxide dissolves in water? When it dissociates or breaks apart, it releases hydroxide ions. The concentration of hydroxide ions in the water solution is greater than the concentration of hydrogen ions in the solution. We call this a basic or alkaline solution. So again, if you just add NaOH, of course, you're going to end up with OH ions, and therefore it's going to be a base or alkaline solution. There's a simpler way of expressing the concentration of hydrogen ions in a solution. The pH. So let's look at our definition of pH. pH is a scale that measures the acidity or alkalinity of a solution. A substance is classified as an acid if it has a pH of less than 7. If it's exactly 7, it is neutral. And if it's more than 7, it is a base. The pH of a solution is a measurement of the concentration of hydrogen ions. pH is written as the negative log of the concentration of hydrogen ions. In other words, pH equals negative log of the concentration of hydrogen ions. So if you look at your scientific calculator, you may see that there is a button labeled log, and that's what it's talking about. It's talking about the logarithmic scale, which you may have talked about in math class. If you haven't, that's okay. We'll cover what you need to for this class. Keeping track of the concentration of hydrogen and hydroxide ions can be difficult. pH is a simpler way to express this. All right, so let's look at logarithm or log. Sometimes there is such a large difference between quantities that simply comparing numbers does not work. When something can be a million times less or a million times greater, the best way to describe the difference mathematically is to use the exponent or power of 10. Logarithms are a way to do this. Think of a logarithm as the power of 10 that the number represents. So when you see 1 times 10 to the negative 7, the log is negative 7. The number shown in the power of 10. Okay, so basically instead of saying, oh, the pH of water is 1 times 10 to the negative 7, they took the log of 1 times 10 to the negative 7, and the answer is just negative 7. It's kind of neat how that works. So they just made them all positive and said, oh, look at that, the pH is 7. And we have a pH table. Different ways of expressing the hydrogen ion concentration of a solution. So the concentration as a number. If something is 0.1 molar, scientifically we call that 1 times 10 to the negative 1st molar. If we do the logarithm, we do it as negative 1, but we make it a negative log, so a negative times a negative is a positive, and that's how mathematically we get it to equal 1. So let's look here. If I have something that's a pH of 2, so it's just the pH of 1 more, really it's times 10 more. So instead of being times 10 to the negative 1, it's times 10 to the negative 2. So instead of being 0.1, it's 0.01. Think about money. Instead of being a dime, it's a penny. So when I say the pH of something is 1 and the pH of something else is 2, that's actually a big jump. That's the difference between having a dime and a penny, or between having $1 and $10, or between having $10 and $100, or between having $100 and $1,000. Okay, so you can see that it's a huge jump. They just simplified it instead of making you write this out all the time. So if I have something that is a pH of 12, that's really 1 times 10 to the negative 12, which is really 0.0000000000001. Okay, so it's all based on powers of 10. Neutral solutions have a pH of 7. Logarithms can seem daunting, but using them makes life easier. The Spanish chemist Soren Sorensen established the pH scale in 1909 to make it easier to deal with acids and bases. The pH, with its simpler numbers, is a friendlier way of expressing a concentration of hydrogen ions, written in brackets as concentration of hydrogen ions. In the example here, note how to use the calculator for solving these kinds of equations. The concentration of hydrogen ions in a neutral solution is equal to 1 times 10 to the negative 7th molar. You can use this information to calculate the pH of this neutral solution. So to compute it algebraically, using algebra, a calculation of pH would look like this. pH equals negative log of the concentration of hydrogen ions. So we said that there's 1 times 10 to the negative 7 molar of hydrogen ions. So we put that whole number here in the brackets. We change the brackets to parentheses, and we take the negative log of that. If you want to break it down, you distribute the negative log. So now I'm just distributing the log. I'm keeping the negative out front. So now I have negative 1 times the quantity of log 1 plus log 10 to the negative 7th. Okay? If you put log 1 in your calculator, your answer is going to be 0. If you put log 10 to the negative 7th in your calculator, your answer is negative 7, and your final answer is 7. And otherwise, you can just put it in your calculator, and you can do that by using the log button. And even if you have this little calculator on your computer, which, oh, great. Now that I want to show it to you, of course it's not working on mine. Go figure. Calculator. There you go. If you have one of these, you can click it so that it is scientific. So if you have one of these in your calculator, go under View, hit Scientific, and then you will have a log button. Woohoo! I know, you're so excited to find that out. All right. So I added to our notes to find pH. We use pH equals the negative log of the concentration of hydrogen ions. And if the concentration of hydrogen ions is 1 times 10 to the negative 7th, then the pH is 7. What about if the concentration of hydrogen ions is 1 times 10 to the negative 9th? Then what's the pH? It is 9. Again, not all solutions are neutral. So this picture shows the pH scale. Remember I said it goes from 0 all the way up to 14. 7 being neutral. Anything less than 7 is an acid. Anything more than 7 is a base. And maybe you remember from a prior lesson, I talked about bases being B words. So bases are bitter, and they turn litmus paper blue, and they are big numbers. So this is what I was getting at with the big numbers. The pH scale goes from 0 to 14 with a value of 7 indicating a neutral solution. What is the pH of an acidic solution? An acidic solution has a hydrogen ion concentration of greater than 1 times 10 to the negative 7. When you use the formula for pH, you will see that the pH of an acid must be less than 7. A basic or alkaline solution has a concentration of hydrogen ions that is less than 1 times 10 to the negative 7. This equates to a pH of greater than 7. Okay, if you're sitting here wondering like, wait a minute, they're saying that it has to be less than this to get a pH of greater than that. Okay, so if that's confusing you, you need to look back here. So here my pH concentration, the pH is higher, right? The pH is higher, which means it's a base. But my pH concentration, if I'd write it out as a decimal, it's a little bit easier to see. Oops. So because it's a 1 with 8 zeros in front of it, versus if I wrote out 1 times 10 to the negative 7th, you can see that it is a smaller number here if I try and line up my decimals. Okay, so that's where sometimes people get confused with that, but this number 9 technically is larger, but it's a smaller number because it's a negative exponent, and that gives you the bigger pH value, which means you have a base. Okay, so if I read that again, it says an acidic solution has a hydrogen ion concentration of greater than 1 times 10 to the 7th, okay? But if it's a base or alkaline solution, it has a concentration that's less than that, which means the pH is greater than 7. So I'm just going to add that last paragraph into our notes as a reminder. And just so you know, if you copy paste, make sure that you watch the fact that sometimes exponents or the arrow keys or the dashes, they come up as weird letters. So if you copy paste, always double check it. Indicator testing. A pH of a solution can be measured using indicator paper. And add acid or base to the water and then test its pH. All right, so I'm going to go ahead and put it here. I'm going to add some base to it. What would be an example of a base? Something that ends in hydroxide, such as NaOH. And then I'm going to take it over here. And what color would you expect it to be, considering that I put it in the base, I added base solution? Well, it better be a greenish or bluish or purple based on how many drops I put in. And it looks like I put in enough drops that, yeah, it's about a pH of 9. Okay, and if you want, you can play around with this, and they make pretty colors, and it's kind of cool to see how many drops you would need of each to get the different colors. So I can put it over here, and remember I have to put it in the sink to empty it, because otherwise, if I just added acid to it, you would have to neutralize it first, and then it could become more acidic. All right, so go ahead if you want to play around with this. Kind of cool. All right, and that's on slide 10. It is possible to calculate the pH of a solution given the hydrogen ion concentration. So a chemist wants to know the pH of rain falling near a power plant. She collects rain near a coal-burning power plant and determines that it has a hydrogen ion concentration of 6 times 10 to the 23rd times 10 to the negative 4th molar. What is the pH of this rainwater? Okay, just to make sure that your answer makes sense, before you put this in your calculator, if I have something that's to a negative 4, what should my answer be close to? Well, it should be somewhere close to 4. Okay, so not exactly, but somewhere close to there. So you put it in your calculator. You put pH equals the negative log of the concentration of hydrogen ions. Put it in your calculator, and you get 3.2. Is that close to 4? Yeah, that's close to 4. So that is what we would have for our answer. Again, practice these before you get to the quiz so that you know how to use your calculator. Here's another one. Here you will see how to find the pH of household bleach. You can start with the hydroxide ion concentration, but you must first calculate the hydrogen ion concentration because pH is a measure of hydrogen ions. So sometimes you have to do some work first. Okay, and I'm going to go ahead and stop the recording here because I'm going to run out of time, and we'll finish up in the next recording.